Okay, so to finish off the circle theorems, we're going to look at tangents. So suppose you have a circle, then a tangent is a straight line that touches the circle only once. So for example, like that. So this straight line touches the circle at exactly one point, and that is called a tangent. Now, one property of a tangent is that it is perpendicular to the radius. So suppose we had a center of circle and then we drew a straight line, that's the radius, then we know for sure that there's 90 degrees. So tangent can only touch or intersect the circle exactly once. This is in contrast to a straight line which cuts the circle twice, called a secant. So if it's a straight line that crosses a circle 2 times, it's a secant, but a tangent is a straight line that touches the circle exactly once. Now, another property of tangents is that, suppose you have a circle, and then you have 2 tangents, so 2 straight lines, for example, like this and this. So we know that these 2 tangents are 90 degrees to the radius. That's one of the properties. Say the bottom tangent touches a circle at a point B and the top tangent touches a circle at point A, and these 2 tangents meet at some external point P where they intersect. So one property of tangents is that the distance from this intersection point to the point of the tangent, these 2 have the same distance, have the same length. So we know that P to A, that distance, has the same length as the P to B distance. So that's another property of tangents. Now, one more circle theorem is called the alternate segment theorem. Now, all this says is, so reference to the textbook is page 145, if you want to cut and paste that diagram out, is that if we have a circle, so we have a circle, and then we have some tangent which crosses at point P, like there, then we say that this angle here from A to P to Y, that is called an external angle, and we say that this angle has the same angle as the internal, the alternate segment angle there. So you're kind of looking for a Z shape, so like that there, a Z shape, but it's the outside angle relating to the tangent, and then it has the same value as the alternate inside angle. So if you consider this outside angle BPX, then it has the same angle as the opposite alternate inside angle there, BAP. So we're going to apply some of these properties with tangents and solve some problems. So example 1, we have 2 diagrams. We're trying to find the value of A degrees in our diagram. So we can see that this length R to A is a tangent because it's a straight line that touches exactly once at the point A. What that means then is this is a right angle. OAR must be a right angle because that's a property of tangents. Actually, that's not an R, that's a B. It got cut off. So we know that angle OAB is 90 degrees. Why? Since the line BA is a tangent, and we know that the radius is perpendicular to the tangent, and radius OA is perpendicular to tangent. So to work out angle A, we've got a triangle here, so sum of angles in a triangle gives you 180 degrees, so A degrees plus 67 degrees plus 90 degrees is 180 degrees. Why? because if you add up all the angles in a triangle, so A is 180, take 90, take 67, which comes to 23 degrees. Now let's have a look at B. So if you look at the diagram, P to A is a straight line that touches the circle exactly once at A, and O to A is a radius, so we know that corner angle is 90 degrees. Similarly, P to B is a straight line that touches a circle exactly once at the point B. So connecting OB, the radius, to PB, we know that that's 90 degrees as well. So we can write down what we know. So angle PAO is the same as angle PBO, which is 90 degrees. Why? Since PA and PB are tangents, and the radius, or radii, OA and OB must be perpendicular to tangents. So we know those two corner angles are 90 degrees. We're told that this outside angle is 220, which means that angles at a point, the inside angle there, AOB, we can work out by subtracting from 360. So we know that angle AOB must be 360 degrees take away 220, because angle at a point, or revolution. So that inside angle would be 140 degrees. Now if you look closely at the diagram, so P to A is one side, A to O is another side, O to B is another side, and P to B is another side. So altogether we have 4 sides of that shape, which means it's a quadrilateral, and angles in a quadrilateral add up to 360 degrees. So therefore we know that angle A plus 90 degrees plus that inside angle of 140 plus another 90 degrees because of the tangent, it all must be 360 degrees, because sum of angles in a quadrilateral. So if you do your subtraction, A is 40 degrees. So that's for the properties of tangents, that the radius and the tangent is perpendicular to each other. Following on, if we look at the next example, which is on page 145 of your textbook, you want to copy and paste a picture. We have another diagram. We're told that XY, so down the bottom here, is a tangent, so it touches the circle only once at point P. We're trying to find angle BAP, so BAP is this top pointing angle there. If we know that BPX, so that angle there, is 38 degrees. So using the alternate angle theorem, if the external angle is 38 degrees, then looking at that Z shape, that pointy internal angle must also be the same. So we can write that, blue pen, angle, so for part A, we can write that angle BPX, which is the top corner one, must be 38 degrees. Why? Because of the alternate angle theorem. So I didn't mention before, but the symbol for alternate angle theorem is just a miniature diagram of what you're applying, literally. That if you have a triangle shape inside a circle, then this external angle must be the same as the interior alternate angle. And for part B, we're told that angle APY, so APY, this external angle is 71 degrees. What is angle ABP, which is this interior alternate angle? It's just applying the same theorem again. So these two angles must be the same. The external angle has the same angle as the interior angle. So we can write that angle ABP is also 71 degrees. Why? Because of the alternate angle theorem. So just draw a miniature version of your diagram. So you have a triangle, tangent, external angle must be the same angle as the internal alternate angle. And that's it for all the circle theorems that you need to know how to apply the different theorems to solve the unknown values. That's a to-do list for exercise 2i. Have fun.